Hey my friend, I hope you're doing fine. Welcome to Joey's Tech. I'm so excited to share the problem of trapping rainwater with you. This problem is interesting, mind-blowing and fun to solve. Not only this video is going to help you up your skills to solve computing problems like such, but it will be entertaining as well. So let's begin the game by looking at the problem statement. Now let's see what the first statement here says. So you are given an elevation map that is represented by positive integers. This elevation map is made of pillars which in turn are made of bars. The height of each bar is given as 1 unit. Now after it rains, water gets trapped in this elevation map. If you are wondering what this elevation map looks like or is it tough, don't worry, nothing complicated. I'll show it to you in the next slide. All you need to do is to find out how much water is trapped in the elevation map after it stops raining. So check this out. This is the elevation map, as you can see, and these are the pillars, and in turn they are made of bars of 1 unit each. So this entire elevation map is represented by an array of integers. 3 over here indicates that there is a pillar of height 3. 0 over here indicates that there is no pillar in this position. 2 over here indicates a pillar of height 2. 0 indicates again that there is no pillar in this position, and 4 over here represents the pillar of height 4. Each pillar is made of bar 1 unit each. So all we need to do is to find out how much water can get trapped in this elevation map. We are going to solve this problem in our framework, but before we do that, a humble request to you to subscribe to my channel if you haven't done it already, and hit the bell icon, because that impacts my ability to create videos like such in a direct manner. Now let's start solving this problem in the framework. Here I have drawn the elevation map. You can see the water trapped inside the elevation map. The amount of water which is trapped in this particular elevation map is 7 units. Now when I first started solving this problem, I thought of traversing the array, and at each position I find out the pillar with minimum height between the pillars on the left hand side and the right hand side of that position, and the height of that pillar is going to be the amount of water trapped in that particular slot. But it didn't work for me because here the pillar with minimum height is 2. Okay, but here the water which is trapped in this particular slot is 3 units. So this is wrong. I am missing one more unit because I am not considering the pillar over here, this pillar of height 4. So the key to the solution of this problem lies in finding the pillar with maximum height on the right hand side and the pillar with the maximum height on the left hand side relative to a particular position. So let's say for this, if we find the pillar with maximum height on the right hand side, which is 4, and the pillar with maximum height on the left hand side, which is 3, then we find out the minimum out of those two. Now that strategy of finding the pillar with minimum height is going to work. So the minimum out of those two is 3. And all we need to do is subtract the height of the pillar in this particular position, which is 0 as of now, from the minimum height that we have got, which is 3 in our case. So 3 minus 0 is going to give me 3, and 3 units of water is stored here. So that gives me the correct answer. So I have two arrays over here, left and right. This left array is going to store the pillar of maximum height on the left hand side relative to each of the positions. Similarly, this array is going to store the pillar with the maximum height on the right hand side relative to each of the positions. And then using the values in each of these two arrays, we are going to calculate our solution. So let's start filling these two arrays. Let's start filling this array. So the value in the first cell will be 3, which I am going to populate from here. Why 3? Because relative to this position there is nothing on the left hand side. So the pillar with maximum height is on this particular position, and that is why I'm storing the height of the pillar on this position here in the first cell. Now we move to the second cell. The height of the pillar over here is 0. Now this 0 will be compared with this 3, because on the left hand side relative to this particular position, our array is going to hold the pillar with maximum height. So this 0 when compared with this 3, the maximum value which we are going to get will be 3, and I'm going to store 3 over here. Now at this cell we have a pillar of height 2. This 2 will be compared with this 3, because until here it holds the pillar of maximum height on the left hand side, because here in this cell it holds the pillar with maximum height on the left hand side. So 2 compared with 3, which is maximum 3. Okay, so I'm going to populate 3 over here. Here 0 will be compared with 3, so again 3 will be populated over here. Here we have a pillar of height 4. So this 4 when compared with 3 is going to give me 4. Now we are going to start filling this array, but this array will start from the right hand side, because relative to a particular position we are trying to find out the pillar of maximum height on the right hand side. So here the base cell will have the value as 4. I have already explained you the reason over here, because there is nothing on the right hand side. So this particular position is going to hold the height of the pillar which is on it. So 4 will be the value. Moving on to the second cell, here the value is 0. 0 compared with 4 is going to give me 4. Okay. Now here we have a pillar of height 2. So I'm going to compare 2 with 4. This cell holds the pillar with maximum height on the right hand side relative to this position. That is what this array is doing. So 2 compared with 4 is going to give me 4. Okay. Here 0 will be compared with 4, so I'm going to get 4 again. Here 3 will be compared to 4, so I am going to get 4 again. Now with these two arrays full, for every position we have got the pillars of maximum height on the left hand side and the right hand side. So let's calculate the water that can be stored in each of the slots. So over here in the first position, how much water can be stored? So we are going to choose the minimum value out of these two, which will be 3. 3 will be subtracted from this 3, the height of the pillar, which is going to give me 0. So no water can be stored over here. Logically also it makes sense. Alright, now for position 2, the minimum value out of these two is 3. Okay, if I subtract 0 from this 3, I am going to get 3 as the answer, and you can see that we store 3 units of water over here. Okay, now over here for this position, the minimum value out of these two is 3. 3 minus 2 is going to give me 1, and you can see that 1 unit of water gets trapped over here, can be stored over here. Okay, moving to this position, we have 3 and 4. What is the minimum value? The minimum value is 3. 3 minus 0 is going to give me 3. That means 3 units of water can get trapped over here, can get stored in this particular slot, and that is what is visible to us. Okay. Over here, the minimum value out of these two is 4. 4 minus 4 is going to give me 0. That means no water can get trapped over here or stored over here. Now we are going to calculate the sum of all the elements of this array, which is going to give me 7, and this 7 is our answer. This 7 is what we are looking for. So after it stops raining, 7 units of water can get trapped in this elevation map. Now let's take a look at its algorithm. This is the algorithm. This is the part where the left array is getting filled, and this is a part where the code will fill the right array, and this is the final part which is going to give you the result which is 7 in our case. This is pretty much ready to be implemented in a program. You can totally use it. This concludes this video on trapping rainwater problem. I hope you enjoyed watching this video. Share your feedback with me in the comment section. Always looking forward to help you with programming and algorithms. Only for this video. Goodbye.